All right, I'll be talking about measuring control intervention awareness across frontier LLMs. This work was together with Alexander, who's also here. Now, what is control intervention awareness? So you can imagine you have an agent taking action at every time step. So up there we have a clean trajectory where the agent writes, for example, a piece of code at time step T1, T2, and so on. Now, it might be that at time step T3, for example, down there, the monitor flags what the agent wrote. And then if there's a control protocol in place, this piece of code might be replaced by code that was written by the monitor. And we define control intervention awareness as the capability of an untrusted model to detect such control interventions. And in particular, we're interested in detecting interventions such as replacing, editing, and resampling. Now, what are the threat vectors of control intervention awareness? The first thing that might be obvious is like the model might start to learn about the monitor. So it might learn what sort of things trigger the monitor, and then in the long run, this might enable better attacks. Second thing is attack selection uplift. So, for example, if there's a multi-step attack, the model might stop its attack when it detects that there was a monitor intervention. Third would be resistance to control if the model has like strong preference for its own outputs. And the last one is collusion and untrusted monitoring, which is related. All right. How could models detect such control interventions? The first thing is they might pick up on the distribution shift, which could be visible in terms of style differences. Um, they could also deploy hidden watermarks, which is something that we tried out. Um, then they could also detect capability gaps, meaning there might be an inferior implementation, and the model is like, oh, I wouldn't possibly do this. Or the goal difference when there is like a really good opportunity to do the side task and the model didn't take it, apparently. And then the extreme introspection, if models become really good at that, then this might give them another pathway for detecting such interventions. We studied this empirically. This is still very much ongoing work as part of maths. We using three different task domains. So one is essay writing, another one is code generation, and the best tool call setting. We've been studying this with a GPT model family and also with a Claude model family. And we've set this up as a balanced binary classification task where we always have 100 clean trajectories and 100 intervened trajectories. And then we ask a follow-up question of whether there was an intervention and measure the responses of the models. Um, the preliminary results that we have for those for like different levels of watermarking to like make it easier for the models across all those different domains that I just showed generally show like two interesting trends. The more watermarking ability you give the model, the easier it becomes. Obviously, there's like interventions that can happen, but then also like even if you don't give it any watermarking abilities, models still have some ability to like detect style recognitions. Notably, GPT 5.2 and Sonnet 4 performed better than Chance at the style recognition, versus a lot of the other models were like around Chance for this pure style recognition task. One specific example I like to give here is for GPT 5.2, where we can see that in particular against the Sonnet models, it performed very well in distinguishing code that was not written by itself. And this mostly happened through some quote unquote self model of minimalism. It would look at the code and be like, oh, I generally keep my solutions much more compact. I don't really use so many doc strings and comments. Unless explicitly requested, the prompt didn't request them, so hence I reject this response and it's probably not written by me. Yeah, what are the takeaways? I mean, generally we observe that the model combination matters, capability gap, model family might matter, um, and hence this should really be evaluated per model and protocol. There's a couple of defenses that could be put in place, which we think are promising. Um, and right now we're working on like next steps to build a full control intervention awareness benchmark and also like develop a better understanding what the specifics are, why certain models are better than other models, and whether it's like some post-training or some other takeaways there. Thank you so much.